So in this video, we are going to learn how to find inverse of a function, both visually and algebraically. So before even we try to find the inverse, we should ask the question, does the function have an inverse? So to check that, we can use the horizontal line test. So if every horizontal line intersects the graph of the function at most once, then the function is one-to-one and it has an inverse. But if the horizontal line across the graph more than once, then the function does not pass the test and has no inverse, so inverse of the function. Okay, once you confirm that the function has an inverse, then you can go ahead and do the algebraic process to find the inverse. Step number 2 actually gives you the first step of the algebraic process to find the inverse. So the first step is to replace your f of x by y. So then the next step is to switch the variables. So you have to interchange the roles of x and y. So actually this reflects the idea of swapping the inputs and outputs. And then you have to solve for y. And finally, you have to replace your y with the notation f inverse x. So that equation, that function will give you the inverse function. So let's try to understand all these steps with some examples. So in this example, you have to find the inverse of f of x. So to find the inverse of f of x, first of all, you have to make sure that this function has an inverse. So to do that, you have to use the horizontal line test. So to do that, again, you have to sketch this function. Okay, so this f of x is a linear function, so hence this is a straight line. So I'm not trying to sketch this perfectly. So what you can do is you can use your calculator to sketch this function. So if you sketch it, it will be a straight line like this. And if you draw lines, horizontal lines, they will intersect with the graph only one time. So that means this is one-to-one. Hence, you can find an inverse for this function. Okay, so now I'm going to move forward and I'm trying to find this inverse function. To do that, first of all, you have to replace this f of x by y. Okay, so instead of f of x, I'm going to write y and I'm going to write the rest of the expression. Okay, so this is your first step. The second step is to switch x and y. So instead of y, I'm going to write x, and instead of x, I'm going to write my y. Right. So after this step, what you have to do is you have to isolate y on one side of the equation. You have to isolate y on one side of the equation. To do that, first step is to move this 4 to the other side of the equation. So let me move that 4 to the other side. To do that, I'm going to add 4 to both sides. Then you will get 4 plus x on this side. On the other side, the negative 4 and the positive 4 will cancel out. So you will have only 3y. Okay, so now I have one term on this side, but still there's a constant. So to get rid of that coefficient, I'm going to divide both sides by 3. In that case, the 3's will go away and you will have y equals 4 plus x over 3. So now y is isolated on one side of the equation. We don't have y in the other side, which means now we are at the final stage. So now you can replace y by f inverse. So now you can replace y by f inverse, and then you can write the inverse function like this. So this function will give you the inverse of f of x. Second example, so you have to find the inverse of this function. F of x equals 9x squared, and remember this function is defined only for all the x values greater than or equals to 0. So this is not defined for negative x values. So we already know f of x is a parabola. So usually it is of shape like this. But since here we are asked to take the function for all the x values greater than 0, you have to consider part of this graph. So let me sketch this. So the graph will be something like this. So it's a parabola, but this goes only to one side. So this is the x-axis and this is the y-axis. So this is f of x equals 9x squared. So remember, we are looking at all the x values greater than 0. We are not considering the function for all the values less than 0. So now if you draw horizontal lines, you can see all these lines will intersect with the graph only one time, which means again f of x is 1 to 1, which implies we should be able to get the inverse of this function. Okay, so now let's do the algebra. The first step is to replace f of x by y. Okay, here I go. And then you have to switch x and y. So instead of y, I'm going to write x, and instead of x, I'm going to write y. Okay, the next goal is to isolate y on one side of the equation. So here it is not isolated because I have a 9 here and I have an exponent as well. So my first goal is to get rid of this 9. To get rid of that 9, I'm going to divide both sides by 9. Okay. Well, the 9's will cancel out and then you will have x over 9 equals y squared. Okay, we are almost there, but this 2 as the exponent is what bothering in this problem. So in order to get rid of this 2, I'm going to take the square root in both sides. So let's take the square root in both sides. So remember, the square root represents the exponent half. So if you're asked to take the square root of a, which means the corresponding exponent is half. So you can actually simplify this as y squared to the power half. So here if you use the laws of exponent, 2 multiplied by half, you'll get a 1. So if you simplify this, you'll get a y here. So that means y is isolated on one side of the equation. So y is equals to square root of x over 9. So now if you want, you can distribute this square root sign to top and bottom separately. So now you can write square root of x over square root of 9 is equals to y. So that means square root of x over the square root of 9 is equals to 3 equals y. So you don't have to do all this simplification. If you want, you can stop at this step, but I did some simplification. So now we are at the final step. So now you can replace your y by the f inverse notation, and f inverse gives you the square root of x over 3. And remember, here actually we considered all the positive values. The x values are positive. The graph is also for positive value, which means your inverse function also defined only for positive x values. So this is the inverse of f of x. Next, we have another example. Again, you are given a function and you have to find the inverse of this f of x. So you can rewrite this function as 4 over 3 minus x over 3. So if you check this out, again, this is a linear function with slope negative 1/3 and with the intercept 4 over 3, and since this is a straight line, this will also pass the horizontal line test. So let me sketch this here. So the intercept is going to be 4 over 3. It will be somewhere here, and the line will be something like this. So you can use your calculator to sketch this, and if you try to do some horizontal lines, all the lines will intersect with the graph only one time. So this is 1 to 1. which means you can find the inverse of this function. So now let's do some algebra to get our inverse function. As we did in the previous example, first of all, you have to replace your f of x by y. So y equals 4 minus x over 3. And then you have to switch x and y. So here I am switching my x and y. And then I need to isolate y on one side of the equation. Okay, again I have a 3 in the denominator. To get rid of this 3, I'm going to multiply both sides by 3. Okay, by multiplying 3, this 3 and this 3 will cancel out, which means on the right hand side you will have 4 minus y, and on the left hand side you will have a 3x. Okay, so now what I'm going to do is I'm going to get rid of this constant. You have a positive 4. So this is the equation. So I can subtract a 4 from both sides. So that will give you here 4x negative 4. And on the other hand, the 4's will go away and you will have a negative y. Well, so we have a negative 1 here, but I need a positive y on this side. To get that, I'm going to divide both sides by negative 1. Okay, so now if you divide 3x by a negative 1, you'll get a negative 3x. And if you divide a negative 4 by a negative 1, you'll get a positive 4. And if you divide negative y by negative 1, you'll get a y. So we are almost done. Now we have to isolate. We already isolated y on one side. Now we have to replace this y by f inverse. So the inverse function of f is negative 3x plus 4. So remember, if you're asked to find inverse function, you have to follow these steps. First, you have to make sure your function has an inverse. You can do this by using horizontal line test. Once you verify that it does have an inverse, you can use these steps to get the inverse functions.